Hi, welcome to another Cold Fusion video. The issue of plastic pollution has been making the rounds in the news lately, but what can we do about it and what is being done about it now? In this video, we'll take a look at the drastic amounts of plastic pollution, particularly in the ocean. We'll also look at the effects that it's having on our bodies and the environment. And lastly, we'll finish off with the featured story of this video, how scientists managed to figure out how to turn plastic waste into jet fuel. It's going to be an interesting video, so let's take a look.
You are watching Cold Fusion TV.
From grocery bags to plastic straws to tiny microbeads and everything from soap to makeup, the Earth is swamped in plastic and will remain so for generations to come.
So how much plastic is there? Well, there's been around 6.3 billion tons of plastic produced worldwide since the 1950s. Looking at this graph, you can see the clear uptrend in plastic production, but interestingly, the effect of the 2008 financial crisis can also be seen. Of this, an estimated 8 million tons of plastic wind up in the oceans every year, and it's pervasive. The World Economic Forum predicts that by 2050, if things continue at the current rate, the oceans will hold more plastic waste than fish. At the bottom of the 11-kilometer deep Mariana Trench, the deepest part of the explored ocean, plastic waste has been found 3 times. One of the most pertinent examples of plastic waste in the ocean is the Great Pacific Garbage Patch. It's a collection of plastic and floating trash, which mainly comes from countries in Asia. There's an estimated 1.8 trillion pieces of plastic here. There's also a North Atlantic garbage patch which is also growing. All of this isn't to mention the effect that it's having on wildlife. Already, this isn't great, but it gets worse. A recent study found that we're eating our own plastic waste. In fact, every week we eat enough plastic to make a credit card. Annually, we eat about 250 grams. This study was carried out by the University of Newcastle, and they state that the most common source of plastic consumption is drinking water. This includes tap water or bottled water. Fish, unsurprisingly, was another source, but interestingly, the other 2 biggest culprits were salt and beer. A lot is unknown about plastic consumption and its effects in humans, but a certain chemical found in some plastics, called BPA, has been shown to reduce sperm count. Apart from all of this, the main problem with plastic is that it just doesn't break down. It's estimated that a foam plastic cup will take 50 years, a disposable nappy 450 years, and a fishing line 600 years to degrade. So don't lose hope yet, we'll soon take a look at what's being done about this issue towards the end of the video. But first, we should take a look at who exactly are the biggest plastic polluters, and where exactly is the source of all this plastic waste coming from. Let's take a look at the data. So the question must be asked, who is the biggest contributor to plastic waste? So looking at this chart, we can see who are the biggest polluters. Number 1 is China, number 2, Indonesia, number 3, the Philippines, number 4, Vietnam, and number 5, Sri Lanka. But note that this was in 2010, just as China was starting their transformation into an industrial economic superpower. From this time, China's industrial output has grown exponentially. It's said that in this expansion, China used as much concrete as the United States did during the entire 20th century. But anyway, overall the situation is a bit more complex, as the United States consumes a lot of goods produced in the East, so one can't really exist without the other. In some good news, China is now making strides to solve these issues, and has reported a 66% drop in the amount of plastic bags used in the past year. About 40 billion bags weren't used. So what are the areas that this plastic waste is coming from? Well, according to a 2017 study, about 90% of all plastic pollution comes from just 10 rivers, 8 in Asia and 2 in Africa. So what sectors are producing the most plastic? Well, by far and away, it's packaging. Packaging leads by 2 times the next biggest category, which is building and construction. Okay, so this sounds all pretty bad, but let's get to the good news about how we can fix this problem. So slowly we've started. Taking a look at this chart, in 1980, about 100% of plastics was discarded as waste. And then in the early 1980s, incinerating started to become practiced. Then in the late 1980s, recycling was brought into the picture, and today, about 45% of all plastic waste is either recycled or incinerated. Not perfect, but it's better than ending up in the ocean.
In terms of our recycling rate, which is one of the key parts of this entire debate, because in theory, if we could successfully recycle our plastics, then we wouldn't have a plastic problem. A lot of experts I talk to insist that we don't have a plastic problem, we have a waste problem.
As shown by this graphic, compared to the sheer amount of plastic produced, it seems that our recycling efforts may just not be enough to solve this problem in a timely manner. We could demand legislation to curb the production of plastics, but we could also look to technology to help. One team of engineers took this task seriously and developed a massive cleaning device to take on the great garbage patch in the ocean that I talked about earlier. Unfortunately, in January 2019, the device did break down and had to be repaired, but it's being relaunched later this year. Perhaps it's better to engineer projects on a smaller scale. These can have an impact on a smaller localized area. 2 rubbish-sucking sea bins were recently installed in Sydney Harbour. The devices suck in water, trapping rubbish in a mesh bag, and recirculate the water back into the environment. There are 450 sea bins in 26 countries around the world, collecting around 4 kilograms a day, or 1.4 tons a year. Another small ocean cleaner, known as Mr. Trash Wheel, is making a difference in the United States. As the wheel turns, it collects litter from the harbour and stores it in the barge later for removal. There are also legislative actions being taken. We all know about straws being banned in certain places, and a lot of store outlets have banned single-use plastic bags. In May of 2019, a new model of collecting packages from consumers began. It's called Loop. Some big-name partners include Procter & Gamble, Nestle, PepsiCo, Unilever, The Body Shop, Coca-Cola, and other firms. But what if we could do even more than all of this? What if we could turn plastic waste into fuel? And here we come to our featured story. A research group led by the Washington State University has found a way to turn daily plastic waste into jet fuel. In a new paper published in the Journal of Applied Energy, the scientists melted plastic waste at high temperatures with activated carbon, basically processed carbon with increased surface area, and the end result was jet fuel. So here's how it works. In the experiment, the scientists ground down waste plastic products like water bottles, milk bottles, and plastic bags down to about 3 millimeters or about the size of a grain of rice. The plastic granules were then placed on top of activated carbon in a tube reactor at a high temperature of about 571 degrees Celsius. The carbon is a catalyst, or a substance that speeds up the chemical reaction without being consumed by the reaction itself. Project lead and associate professor Han-Woo Lee speaks, quote, "Plastic is hard to break down. You have to add a catalyst to help break the chemical bonds. There's a lot of hydrogen in plastics, which is a key component for fuel." End quote. Once the carbon catalyst has done its work, it can be separated out in the next batch of waste plastic conversion. The catalyst can also be regenerated after losing its activity. After testing several different catalysts at different temperatures, the best results they obtained was a mixture of 85% jet fuel and 15% diesel fuel. Lee speaks again, quote, "We can recover almost 100% of the energy from plastic we tested. The fuel is very good quality, and the byproduct gases produced are high quality and useful as well." End quote. He goes on to say that this process is easily scalable. It could work at a large facility or even on farms where farmers could turn their own plastic waste into diesel. Lee speaks again, quote, "Waste plastic is a huge problem worldwide. This is a very good and relatively simple way to recycle these used plastics." End quote. Another research team at Purdue University has invented a way to convert 90% of plastic waste into many different products, including pure polymers and fuels. Linda Wang, professor at the School of Chemical Engineering at Purdue University, speaks, quote, "Our strategy is to create a driving force for recycling by converting plastic waste into a wide range of valuable products, including polymers or clean fuels. Our conversion technology has the potential to boost the profits of the recycling industry and shrink the world's plastic waste stock." End quote. So going back to the jet fuel story, it's not perfect, as burning fuel will of course result in greenhouse gases, but it's a big step above what we have now for those countries who don't have the environmental awareness and don't see much issue with throwing plastic in the ocean. It all comes down to the profit motivation aspect of the equation. If money can be made by producing plastic waste-based fuels, this could be a financial incentive for governments and private companies alike to heavily recycle and put in place better methods than landfill. And besides, do you want to keep eating increasingly more amounts of plastic each year? I do encourage the kind of work that these scientists are doing, and hopefully we can see it implemented on a large scale soon. So really, with this video, I just wanted to start a conversation about this problem and the early solutions that are being developed. It's a real pity that more people don't know about this kind of thing. You can help change that by clicking the share button. Anyway, thanks for watching. This has been Dagogo and you've been watching Cold Fusion. Don't forget, if you want to check out the podcast versions of these videos, I'll leave a link to that below. Alright, so I'll see you again for the next video. Cheers guys. Have a good one.
Cold Fusion. It's new thinking.